Okay, all right. So any questions? Shall we use whiteboard or use whiteboard? Okay, question, please.
How do we use the first principle method?
In calculus, right? Oh no, in the first principle of the derivative.
Yeah.
Yeah, that's what you learn in the at the beginning. Yes. Do you know the principle? Do you know first principle? Do you remember the principle? How do we define the first derivative? Using the first principle, right? Using the first principle. What is this principle? Do you remember?
Is it?
Can you write down? Can you write down? To find the first derivative, right? To first find the first derivative, dy dx. Yep, that is a limit. Yeah. There's the first derivative. Can you see the first derivative? Nearly. Can we write a limit first? There's a limit. So can you write it down here? Yes, h, yeah, h is here. So there's first you have to write the limit. You didn't write the limit, you see. H approach to 0. And this is a delta, delta f multiplied, this should be delta x. X is actually, h is equal to delta x. You see. So h is equal to delta x. Okay, yeah, you're right. So you need to put a limit here, right? Put h equal to there. That's it. Okay, that is the first principle. That is the definition. Okay. So that is answer. That's all.
But how do we use this then?
Oh yes, you can go to example. Can we go to example? Yes, that's a good idea. Can we just show you how to use that? Can we say fx equal to, can we start from some simple? Can we say fx equal to x squared? What can you do? How can we find the first derivative? By using the first principle. Do you want to try? Not a formula. If you use a formula, that question becomes rather simple. At this stage, there's no equal sign, okay? You can, at the beginning, there's, before you use limit, they are not equal, all right?
Yeah.
You have to find the formula for the, so can we say, first of all, can I show you? First thing you need to do is to find the delta f over delta x. That is the objective, right? After that, so can you see that? First, you found this ratio and then use the limit. Two step, okay, two step.
How do we find that ratio?
Well, you can expand, can you see? Can you expand? Yep, can you simplify? Yeah. That's right. Okay, this is step 1. Step 2 is to use a limit. Okay, so you just found the limit of this ratio when delta h is equal to 0. We know this ratio now. Now you have to use this second. You have to find this limit. What is the limit? Can you tell from your previous result?
When h is equal
approach to 0, yeah, when h approach to 0. What has left, or what would happen rather when h approach to 0? So basically, this is your formula. Can you see? So the delta F, you got this ratio already. Delta X equal to this part, equal to this formula. Can you see? So what would happen if H approach to 0? That is the idea of limit, okay?
It would be equal to negative.
Negative. Where does negative come from?
Or would it be equal to 2x?
Of course, of course. Yes, can you write down? That's it. Therefore, you can argue that this formula, the first derivative, is equal to 2x. Can you see? This time you didn't use the formula, but just use the first principle. Got it? Which is identical to the formula, isn't it? Does that make sense?
Why does the limit equal the derivative?
Ah, that is a non-story. So at the beginning, so you have, that is, yes, probably you forgot this introduction, or did the teacher draw this diagram properly? So the original question to invent the background, why Newton want to invent this first derivative formula or algorithm, if you wish, is that he think, just to the point like this one. So basically, he want to find the slope. Okay, he need to find the gradients at this particular point x. Can you see? And this is y, this is fx. So this curve represents fx. So the objective of this Newton is to find the first derivative, just like velocity. Can you see?
Yeah.
We need to find the gradients at this particular point. If this f is this position and this slope, this gradient will be the velocity, right? So the objective is to find this angle. Can you see? Can we call it alpha? Can you see? Because these gradients, the instantaneous gradients is equal to tan alpha. Do you agree? So how did Newton organize out? He just introduced a 2 point. He used approximation first. Can you see? Can we just draw this position, the Q? So they just let the x change, become x plus h, all right? And again, h equal to delta x anyhow, right?
Yeah.
So in this way, he can accurately work out another angle. If I draw this angle for you. So in this case, they draw another straight line over here. Can you see? So in one moment, draw another straight line. Okay, the yellow one. So in this way, he can accurately work out this triangle here. Oops. Right angle triangle. Yes. Can you see the right angle triangle here?
Yeah.
So they can call it PQR. So this is right angle triangle. Now he said he knows that in this way he cannot still get alpha, but he can get another angle, which is called beta. Can you see this angle here? So this is called beta. Of course, in this case, beta and alpha are not equal, right?
Yeah.
So beta is not equal to alpha if h is not equal to 0, all right? For sure, right? So therefore, however, he should be able to write, so that's why we write this question first. The delta f, but he knows that delta f over delta x must equal to tan beta. Do you agree? In this triangle. And just probably just highlight this difference. So that is how the Newton invented this calculus. So this is fx, do you agree? And
Yeah.
this would be the fx plus h. because x value increase and the function change. Can you see?
Mm-hmm.
So this side is called delta x. Okay. This side, the longer side, is called delta f. Do you agree?
Mm-hmm.
Okay. So that is why at the beginning, that is why in the first I ask you to step 1, can you see? We need to find this delta f, delta x. Can you see? All right.
Mm-hmm.
And that is equal to our tan beta. Do you agree?
Yeah.
Now, as long as this h is large, and they are not equal, all right? However,
Mm-hmm.
if h is small, okay, it's very small. You can imagine can you imagine this q can move? Can you see? Can we decrease our h? If h is small, then we can argue that the beta is approximately equal to alpha. Do you agree?
Mm-hmm.
Can you see this trend? When q is a approach to p, this will be close. Can you see? Another thing, if h is approach to 0, beta will equal to beta. Can you understand these two arguments?
Yeah.
Okay. So therefore, in this case, the tan alpha can be written as, so tan alpha can be written as the limit of tan beta when h approach to 0. Do you agree?
Mm-hmm.
Okay. Therefore, the first derivative we are looking for, by the way, so this tan alpha, so this gradient is also denoted as the prime. Can you see? Or you know that we also use the df dx. Can you see? The gradients. So can you see? So therefore, the gradient can be written as this form. Can you see? Limit when h approach to 0, and this ratio delta f delta x. That is the first principle. Can you follow me? I should write down here. So basically, this first derivative is equal to the limit. Can you see? Delta f delta x when h equal to approach to 0.
So will
Any
the
question?
limit be equal to the derivative when h
Well, two questions. You asking what is limit, right?
Yeah.
Well, limit is a mathematical.
I don't understand why this is equal to the derivative.
Oh, you didn't follow me. Can you watch carefully? Okay, at this time I highlight something I'm talking about. Do you agree the gradient can be written as tangent alpha? Do you agree?
Mm-hmm. Yeah.
Do you agree the gradient can be written as this form? Do you agree?
Mm-hmm.
Of course, at the beginning, this tan bar alpha has nothing to do with the gradient. Or, well, related, not equal to. Do you agree?
Mm-hmm.
However, if we decrease this delta x or h, right? Eventually, we got this approximation. Can you see? Can you see that?
Yeah.
At the beginning, these two are not equal for sure. But if h is small, we can see the trend, the change of trend. Can you see?
Mm-hmm.
Now, let's go to extreme. So this is very important. At this extreme, these two angles become equal. Do you agree?
Yeah.
When these two angles become equal, then there's no difference between tangent alpha and tangent beta. Do you agree?
Mm-hmm.
So
Yeah.
that is why, in short, we use this notation. at the beginning, alpha and beta, at the beginning, alpha and beta are apparently different. However, if we decrease the delta x small enough, we can argue that they will become identical, provided h approach to 0. That is how calculus was invented.
Yeah.
You can solve some high level problem, but this is foundation. Can you see? This is the first important thing to know when you start calculus.
Yeah.
Are you convinced?
Yes, I get it.
Yes, okay. So Newton is very clear. I tell you another story. So mathematicians before Newton didn't reach that point because they don't want to go ahead. Do you know why? Because if you just look at this form, when delta x equal to 0, what would happen? They will become something undefined. Can you see? Before you start calculus, your teacher, mathematical teacher, always tell you, stop, it's undefined. Do you agree?
Yeah.
So did other mathematicians. But unlike other mathematicians, Isaac Newton is a physicist. He studies a comet in the sky. Comet move, all right?
Yeah.
Other mathematicians just fix this P and Q. They say, hey, Newton said, wait a moment. If I just let this point just like a comet move to approach this P, what would happen? So because he asked this very, very novel question, he eventually solved this puzzle. Do you know what I mean?
Yeah.
So when we started the calculus, you have considered the variable can change, okay? You can imagine that point can move, all right? It's simple. If you can think that way, the Newton's idea is rather simple. He said, well, let's just move, all right? And another thing other mathematicians fail to understand is that during this process, not only delta x approach to 0, okay? As delta half is also approach to 0, can you see?
Yeah.
So the correct answer is that how do we deal with this issue rather than this one, can you see? So in Newton's idea is that Newton is the first person to say, well, let's consider this question rather than this question, all right? So Newton asked because Newton asked the correct question, he solved the problem.
Yeah.
The derivative problem has nothing to do with 1 divided by 0, but 0 divided by 0, okay? So 0 divided by 0 could be finite, not infinity, all right? If one divided by 0, what is the result? Infinity. So that is really undefined, okay? Okay. Next question.
How do we use the first principle to figure out a limit? Because that was one of the exam questions. I can write down the question.
No. This question is too overgeneral. You have to ask the concrete example, okay?
Yeah, I'll write down the question.
You don't want to follow their the curriculum authorities or wording, okay? They have nothing to do, just make trouble for teacher and students, right? You can tell me you can pick up the right relevant question. I can show you how to solve. Yeah, so this is part of the knowledge you can use, right? So instead, they just n is what is? Can you write carefully? Is this h or?
Yeah, it's h.
Can I write down here? So basically, you are looking for this. This is 12. Is 12 to the power h, right? Yeah, divide by h, right? Yeah. So that is one. So when obviously when if you don't use if you don't use any further treatment, you will come of it looks like so 0 divided by 0, right?
Yeah.
But exactly, the question is what is this ratio you need to find out, okay? Now, this question, can we call it question 1, or this should be question 2 now, all right? Question 2.
Yeah.
So this question is related to how to we dealing with numerator. Do you know any way to simplify the numerator? 12h, take 1. Can we rewrite this one? Can we expand? No? Use this formula. Yes, because we when we were how to say when we do you know this formula? So this is an minus bn. Do you know this formula? How do we expand this formula?
Yeah.
Any form? Can you check your formula?
Oh wait, no.
No.
That
no.
is. You have to do the change of base.
Yes. I tell you. It's in algebra. Can we? Oh, you change the base. You rewrite as a base, right? Log 10.
Just log anything, right?
Is that true? Where is n? Where does n go? Where does n go?
Not sure.
Probably not. This is not the right answer. It's not the right question. Yeah. So this type of question is how do we simplify? How do we write? So this question is related. How do we possibly simplify this numerator? You see. And because you haven't studied much, so basically we should be able to expand this one. Have you studied Taylor series? You haven't studied Taylor series. If you want to expand that, basically I tell you a method. Okay, the method is that if you do, they have to ask you to use first principle.
They just say find the limit, I think.
You just find a limit, all right? Find a limit. Okay, that's fine. So we really have to use some algebra to rewrite this numerator. Okay. And let me see what are the options? 12 is 12. Can we just rewrite 12? Can you see? Can we rewrite 12 as something else? Can we? Can we just rewrite 12 as 11 plus 1 to the n? All right. Can we do that? Now, do you know how to use can you use knowledge of the plus 1, sorry. Can I use the alpha plus binomial theorem? Do you remember this formula? Can you expand that? Check your formula. What is a binomial theorem? It's useful when you study the probability. It's sigma. Can you write down here? That is n k. That is n k from 0. Do you know the formula?
Yes. It's
yes. Of course, you should know. Can you see that's k? That is n minus k, right? Go on.
Sorry.
Yeah, this is formula. This is binomial theory. You can apply this formula to expand. Oh, before you go, hang on, I give you some hint, okay? Before you go, can we factorize this 11, all right? And that will be, oh, no, I don't want to factorize yet, okay. Can we just can we find the first few term? Can we, what is k equal to 0 term? Can you just use this formula? What is x? Yeah, going backward. Can you see? You start from, oh, it is from, you k, this k equal to 0. Do you agree?
Mm-hmm. Yeah.
Yeah.
I don't understand.
I think we just do something simpler. Can we just consider this h is any number? So basically, because n is so basically you have expanded this one. We got 11 and 1. At one moment. So this is a tricky question. So basically, they are not asking you algebra. They are not asking calculus. That is algebra, right? If we just expand this one, if this can be rewritten as 1 plus something, all right? I tell you what, that's the direction to go. If you can rewrite this as 1 plus something, can you see? Plus some h, all right? And in terms of another thing, h squared, can you see? And so on. Can you follow me? So therefore, yes, therefore, if you can do that, then we can, I give you a direction to go, all right? Then we can say 12 to the power h minus 1, where approximately equal to this one multiply h plus this one plus h squared, and so on. Can you follow me? I just tell you the direction to go first. If that's so, therefore, this mathematical form divided by h can be rewritten as, can you see? Rewritten as divided by h is just this form, can you see? They became, the second part become h and so on. They are just higher order, can you see? This kind of higher order h. So if that's so, that would be your first derivative. Can you follow me? So this term will be your first derivative when h approaches to 0. This is the direction to go. So finally, we can argue that limit, can you see? And 12 to the power of h, take 1 divided by h. Can you see when h approaches to 0? That will equal to this radical term. You understand? So basically, we have to find out how to solve this first equation first. Can you see? We have expand 12 in terms of this power form of h. Can you follow me?
Yes.
Yes. Do you want to try? Can we just return to can we return to the binomial distribution? We have to reconstruct that one. That's how we do this problem. Okay, this is method. So this is a method you can use. So you really have to consider how do we start. So we put the question here. So really we have to rewrite these ones. In this case, for the, how can we write something? Basically, we need to rewrite this 12 Let's write down from here. How do we rewrite this form? Okay. And first thing I write is as a sum of 11 plus 1. And let me see if it had other. Yeah. Do you want to continue or not? Hello?
Wouldn't that get too complicated?
Well, it's not complicated. You have to find the way to rewrite this in terms of this this form, okay, binomial. You have to use this binomial. If I just because I did two form here, so we need to can we rewrite this as 1 plus? Can we use 1 plus 11 rather? Oh, the base is changed. No, the base is changed. I think it's not worth it. All right. Where did you get this question, by the way? From your past paper?
Yeah.
From your textbook?
It's from a past paper.
It's from on past paper. I understand. Yeah. Yeah. So basically, this is a method. Okay. And whether you can solve this puzzle depends on how you rewrite this this power by using binomial. Okay. Binomial, they got a different term, right? They got different term here, so therefore you should be able to work out this term with h. Okay.
Yeah.
In other words, put in other words, so this is something you haven't studied, but I can tell you. So any function, can you see? Any function can be written as what we call the Taylor series. Okay. Got a Taylor series. Put something k here. This is k. So another way to go is to use the Taylor series. Okay. You haven't studied this one. I understand. All right. Forget about this. Then there's no point. This doesn't. They wouldn't ask this question. Nobody know, right?
It's on the past paper.
Okay. Check your answer. Okay. Check your answer. Okay. Check your answer. Go to the answer to see how do they use this binomial theorem. Okay.
It's a multiple choice question, so they don't give
multiple
us
choice.
the
Okay.
working out. They just give us the answer. So for them the answer is
is a derivative of the exponential function.
Is it?
Well, I think this is you can also argue that there's another way to do it. I show you another way. Okay, if you got a ratio f divided by g, okay, if you found the limit, if you found some limit, right? In this case, h approach to 0. What you can do, you can use the first derivative. Okay, but this is not use the first principle. If you use the first, if you use this one, the denominator become 1, the numerator become 12. Can you see? 12 h minus 1. Can you see? So in this way, if I use first derivative, what do we have? When h equal to 0, oh, it's not your answer. This is not your answer. Are you sure this is the right form of the paper, the question?
Yes.
Yes.
It says
Well, yes, just return to the question. You have to use binomial theorem, okay? You have expanded that. I told you this method. If you have time, you can spend more time to do that, all right? This direction to go. You have to expand that, all right? But at this stage, tomorrow exam time, there's no point, okay, to solve every question.
Would we do it like this?
Use the log. I can't see you writing, so you added the term.
Like just derive it first and then use that formula?
You multiply something. No. This formula is useful in some case. Okay, not necessary in this case. This formula
because this wouldn't.
Yeah.
For this one,
Yeah.
wouldn't we use the quotient rule to figure out the derivative?
No, that's if they are looking for the first derivative, you have to use you have this stop here. You have to use you have expanded this term in this form so that the first one will be cancelled by this one. All right. Do you understand? There's a negative one here. This will cancel this first one. All right. But how do we do that? Then you have to expand this one. Let me do that. I think sometimes you're trying to solve everything, but it's not worthwhile. Can you see? If you wish, we can spend more time. If we just rewrite this as 1 plus 11, can we do that? Can we call this? You have to check your formula. What is alpha plus? So not h. What is alpha plus beta? Can you expand this? First term is 1. Okay. Write the first term as 1. If you compare with that, what is oh, sorry. The first term is alpha to power h. Do you agree? How about the second one? Can you write it one? If you want to solve the problem, you have to find that formula first. All right. What is the formula for this one? Let's go on. Good. So what is coefficient? What is coefficient? Is 1 or not? It's this formula. Can you see? This is this formula, right? Use h multiply this first one is 0, right? So what is the formula? What is the formula for this combination formula? Yes, I just clear up this part. You can see it clearly. What is say no? What is say no?
Oh, that's 0. That's
0. Ah, it's 1. Oh. Oh, it's just 1. That's good. Good. Okay. N minus 1. Yes. H minus 1. Yeah. The importance is you need to find this coefficient, right? Okay, go on. So that's the right way to go. So this is formula. Now
for the question, for that one question, we just have to substitute a very small value of h.
Not now. Not now. You didn't follow me. You didn't follow my suggestion. You cannot. You cannot just substitute h equal to 0. You will end up with this one. Okay.
What if we make it very small, like?
You didn't follow me. You didn't listen to what I'm talking to you, told you. I said, please expand this one by using the binomial theory so that the first term will be 1. Is the first term 1? Can you see?
Yes.
That's it. That's what I'm looking
But
for. Do you know
we don't know what these terms are. We don't know what alpha and beta are.
Sorry. Yeah. We know alpha. We know alpha is 1. We know beta is 11. Of course we know. In this case, if you compare what is alpha, what is beta?
Then if we don't know what H is, can we solve this?
No, we don't. H is there. H is always there. You see.
Mm-hmm.
Go on. You can. We solved the problem already. You didn't see it. Can you try? If you put what I said together, you should be able to solve this by now. See. Equal to 1. Are you sure?
Wasn't that the thing? Wasn't that what we did before on the other page?
Okay, you have look. Yeah. So you have look. Everything I have written down here. Yes.
Oh,
please don't just use binomial, but use binomial. Yes. But what is the red corner? You have to be able to find what is the red corner one. This just a sketch. In this sketch, I outline the method. All right.
Mm-hmm.
But this is not the solution. This is the method. Okay. This is my notation of the method. And on this page, I show you how to do it exactly. All right.
Mm-hmm.
But there's there's nothing. So I didn't say that. Can you try again? I didn't say this at all. No.
So this is what we want to find.
You can work it out. You use the formula, please. You use the binomial theory. I told you already. We know alpha, we know beta. What is the coefficient? C1, what is C1?
This one?
Yeah, what is the number? You are looking, well, I'm looking for the number. What's
that would be equal to H.
Do you think so?
Does HC1?
Look, you really have to use this formula. I can write the formula here for you again. You really have to get familiar with this formula. Okay, that is n. In our case, n is H. All right, but I use the general formula. K from 0. K from 0. But this time we are looking for alpha. So you have decided anyway. You have decided, have fun. You have decided how to put what is F, what is beta. Beta, can you see? So if this is K, that would be n minus K. All right. So when K equal to n, beta became 1.
Yeah.
So you have decided in these two number which is alpha and which is 11. Sorry, which is 1, which is 11. You see that they have two number here. Or do you think so? So how can we got the first term to power of n? Are you sure? I think it's other way around, isn't it?
Yes, because 1 to the power of n will always be 1.
So we are looking for the backward formula. All right. Oh, forget about limit. No, forget about limit. we are not dealing with limit. You didn't follow me. We are rewrite the we are rewrite the denominator. We are not jump to the limit in the first place. All right. All what we have doing is that how to rewrite the okay. On this page, we are dealing with how to rewrite this form, this number. All right. So this is the first step. So we are not in a position to use the limit yet. All right, forget about limit.
I don't understand how to solve this without h, because otherwise we'd just be going on forever, right?
Oh, this is general formula. This is general formula. So you confuse this one. So if this is this is general formula, okay? This is general formula where I can either use h. Should I put a h here? You can either use h or you can use n, up to you, all right? Because it doesn't matter, it's just algebra. If you use h, this will be the h, all right?
Yeah, so what are we solving for here?
Well, basically we are looking for mathematical form so that the first term, we know that the first term will become 1. And this one is useful because this one can be canceled by this guy, all right? And in other words, if you just look at my method here, apart from 1, then we expect this other term will contain h, all right? And h squared and so on.
So we get.
Oh, hang on. I give you another direction to go. I just realized if I can rewrite 12, how can we invoke h here? 12 to power h. Yeah, we can't. We have to use this binomial. Yes, unfortunately, we have to use binomial. Where's the 1? What I'm looking for the first term is 1.
Didn't we already cancel out 1?
What do you mean you cancel out? Yeah, that's right. That's work. Yeah, that's right. So certainly this is not. So this is this one. Can you see? You are looking for this formula. Yes. Okay, that's better. So any other term you can edit?
Oh.
There probably more than one term, right? Higher order term.
But if we get a higher order term, won't we just be going on forever?
No, that depends on what is the form is, you see. Really, you have to looking for what is the formula for this one? Is that just 1? Is this 1? Can we write the formula here? Is this 1? Yeah, I think so. Can you see? 0 factorial and n minus 0 factorial is 1, right? So this first coefficient is 1, but don't confuse with, you have to check the order, okay? Because in this way, in this formula, can we expand this? This first term is 1, the coefficient is 1, but alpha is 0. Can you see no alpha in the first term, no alpha. And the secondly is beta, that is n. Can you see? The second term is n1. Can you see? That would be alpha 1. Can you see? Alpha 1. That is that's beta. That is beta. Oh, that's beta. Oh, use beta as 1. Okay, beta as 1. So this will be beta and take 1, right? And let's go. How about next one? Next one will be n2, right? We just use this formula now. And use this formula now, and that equal to alpha square, right? Alpha is 11 squared and beta to the power. So beta is always 1. We don't have to write beta. Beta is 1, okay? So we can simplify this without writing this part. It's just alpha squared, can you see? Because beta is 1. Do you agree?
Mm-hmm.
Okay. The question is, can we get this, can we just rewrite this down here? Okay, so alpha is 11, right? So first term would be 11. Alpha is 11, right? Oh, sorry, alpha is 1. So alpha is 1. First term is 1. Do you agree? First one is 1. Can you follow me?
Mm-hmm.
The second one is, how about the n to 1? Oh, you tell me, please. N1, can you tell me this number, please? This should use a hedge. Can we use a hedge? Yeah. Equal to n, are you sure? Good. If that's n, we are looking for n, yes. Just exactly equal to n?
Mm-hmm.
No, you tell me, please. I'm waiting for your answer. What is the answer here? If they got n, that's what I'm looking for. Yes, because we are going to cancel this n. Okay. N. Okay, it's n. Okay, so that's good. Good news. Can you see?
Mm-hmm.
This is coefficient n. Okay, alpha is 1. Do you agree? So the second term is 1. Okay. How about third term? Let's go to third term now. Alpha is 1. Good. No, alpha is 11, right? Oh, second is 11, huh? Second 11n. Do you agree? 11 multiply n. Okay. How about third term? Second term is 11 squared, right? Oh, that just increase. Oh. So what is this coefficient anyway? Yes, what's that? H square, I think it's at least H square, I hope, n square, right? No, what is that? Not, you have found it out. You have to use this formula to work them out, can you see? Give some space. What is n pick up 2? N again, or n square?
N over 3.
Oh, I see. No. I'm looking for this number. Can you expand that?
Oh.
What is n2? Because we need this number now. Aha, yes, you got n squared. Yes, okay, that's what I'm looking for. Can you expand that? Can you simplify this? What?
I'm not sure how to expand it.
No. That's right. Can you see? If I just rewrite the first term, 2 factorial is just 2. Do you agree? 2 factorial equal to 2, right? But n factorial can be written as n minus 1. You see? And n minus 2. This is something very useful. So denominator is n minus 2 factorial. Can you see that? So therefore, Can you simplify? You should be able to simplify. How can we simplify this form? How can we simplify this form? This is n. Can you use your algebra to simplify this form? Yes, you got n square form here. Okay, good. Okay, so basically what happens is that as this increase, you will see this term. Can we write this formula for you now? This term will be equal to 11, right? Multiply n, and this is 11 squared, right? Multiply something to do with n squared, you see?
Yeah.
Plus minus n. Minus n, okay? So that is very close to your answer now. You can, if you want to continue, it's up to you, all right? But I think this is totally unworth, all right? Because this is quite a rare question, all right?
Yeah.
And there's no point to spend 1 hour on this question. I think it's not necessary, all right? Please pay attention to the first part of our talk, okay?
Yeah.
Because you can't solve every question. Besides this question, once you know the method, you don't have to spend the time. They wouldn't ask you this question. I 100% sure. All right.
Yeah.
Okay, I will stop here now. Let's. So that's all for your tutoring this week. Yeah, do you agree?
Okay.
Okay.
Sure.
So good luck for your test. Okay.
Okay. Thank you.
You're welcome. Goodbye.